Okay, I want you to picture a scenario, and I guarantee this has happened to you.
Uh,
It's Friday night, you're exhausted, you've finally settled onto the couch to watch that new show everyone at work is talking about.
yep, I'm with you.
You fire up the smart TV, you navigate to the app, and then the login screen appears.
Oh, the login screen of death, the absolute vibe killer.
It is the modern definition of torture. You are holding a remote control that was, designed in 1995?
Probably.
You have 4 directional arrows, up, down, left, right, and an enter button.
And a 20-character password to type.
Letter by agonizing letter. You
Yes.
miss one character, you have to navigate all the way back.
And you sit there thinking, I have a supercomputer in my pocket with a full keyboard. Why am I doing this?
It's genuinely painful.
It is.
And that friction, that absolute disconnect between the smarts in our heads and the dumb plastic bricks in our hands is exactly where we are starting today.
Boom.
We are doing a deep dive into U.S. patent 12,346,399
Which was granted just recently on July 1st, 2025.
to an inventor named Edwin A. Hernandez Mondragon.
And while the patent title is a bit of a mouthful, method and system for a web interaction with objects and remote display technologies, the ambition here is actually very simple.
It's about killing the remote control, isn't it?
In a way, yes. But it's also about killing the remote control app.
Ah.
You know how every time you buy a new device, a new speaker, a new TV, they want you to download their specific app to control it.
Right, my phone is full of them.
This patent, which describes a system often called the Device Connect Platform, or MEVIA, says, no more apps, no more plastic bricks.
So the mission is to turn the smartphone you already have in your pocket into a universal, context-aware controller for any screen you look at.
Exactly.
Yeah.
But, and this is a crucial hook, without you ever installing software in your phone.
That's the claim that stuck out to me, because I feel like we've heard this promise before. Universal control has been the holy grail for a decade.
It has.
So why hasn't it happened yet? Why do I still have 3 remotes on my coffee table?
Well, the patent background actually does a really good job of diagnosing that failure.
Oh, interesting.
It points the finger at the underlying technology we've been relying on. Historically, if you wanted to control one screen from another, you use things like RDP,
Remote desktop protocol.
right, or VNC.
These are the tools IT guys use to fix your computer from a different building.
Correct. And they are heavy. Think about what RDP is doing. It is constantly taking screenshots of the remote screen and streaming them to your device as a video feed.
Which takes a lot of bandwidth.
A ton. It requires specific software to be installed on both ends. It eats up battery life like crazy. And most importantly, for a user interface, it lags.
It feels clunky. If I walk into a hotel room, I'm not going to download a hotel RDP client just to change the channel on the TV.
Precisely. The friction is too high. The Device Connect platform in this patent proposes a complete shift in architecture.
Okay.
Instead of heavy protocols streaming video, it uses what it calls a decentralized operating system model.
And that leverages...
The one tool that is already on 100% of smartphones, the web browser.
So the browser becomes the universal translator.
That's the core insight here.
Yeah.
The intelligence isn't locked in the TV hardware, and it isn't locked in a downloaded app.
Right.
The intelligence lives in the web connection between them. Your phone transforms into whatever tool the TV needs it to be at that exact second.
Okay, I want to get into the chameleon aspect of this because the visual examples in the patent are wild.
They are.
But first, we have to understand the mechanism. Because as a user, I'm skeptical. How does the handshake happen?
Let's walk through it. This is the scan and play process described in figures 5 and 6.
Okay.
So imagine you walk up to a smart TV running this MEVIA system. On the screen, you see a quick response code, a QR code.
Right, like a restaurant menu.
Exactly. But usually when you scan a QR code, it just opens a static website, right?
Yeah, a link, usually a PDF that's hard to read.
Here, it's a digital key. That QR code contains a session ID, a UUID, and encryption keys that are unique to that screen and that moment.
So I pull out my phone, my second browser, as the patent calls it, and I scan it.
You scan it. Your phone opens a URL. But then the system performs what the patent calls an injection.
Injection. That sounds a little aggressive.
It does, but in web terms, it just means the server is sending active scripts to your browser to run locally. Things like Mevia.js or gestures.js.
So it's like how Gmail or Spotify works in a browser.
That's a great analogy. But once that code is running, which takes milliseconds, your phone establishes a two-way persistent connection with the TV.
And this is where the magic happens, because my phone doesn't just show a generic remote control interface with a volume knob.
No. And this is the chameleon feature. The TV tells the phone what it needs.
Context awareness.
Right. The interface isn't static, it's dynamic.
I was looking at figures 2 and 8 in the patent. The examples are so logical, it makes you wonder why we aren't doing this already.
Let's look at scenario A gaming. The patent explicitly mentions retro games like Pac-Man.
Okay, so if Pac-Man is running on the big screen, what happens to my phone?
Your phone screen clears, and it instantly renders a game controller.
A D-pad.
A D-pad up, down, left, right, and action buttons. It looks like a Nintendo controller, but it's rendered entirely in Safari or Chrome.
Without me opening a game app.
Right. The web page is the controller. And if you switch the TV to a drawing app.
This is scenario B, right? The
Right.
NFT lab or paintbrush app.
Exactly. If the TV is in creative mode, your phone interface wipes the game controller and replaces it with a palette controller.
So my phone becomes a trackpad.
The trackpad and a color wheel. You drag your finger on your phone glass and you see the brush stroke appear on the TV.
And then scenario C, the one that solves my Friday night Netflix problem.
The keyboard controller.
Thank goodness.
As soon as a text field appears on the TV, whether you're searching or logging in, the system detects that.
And triggers my phone to load a full QWERTY keyboard.
So you're typing on your phone with your thumbs the way you're used to.
But the letters are appearing on the TV.
Instantly. And think about the efficiency. You didn't open a keyboard app, then close it, then open a game app.
The one web page just reloaded itself based on signals from the TV.
It's fluid.
It sounds great, but I have to play devil's advocate here. Fluidity is one thing. Speed is another. If I'm playing Pac-Man and I press left on my phone to avoid a ghost, if there is even a half second of lag, I'm dead.
Of course.
Cloud gaming has always struggled with this. How does this patent address latency?
That is the eternal challenge. And this is where the patent gets really interesting technically. It differentiates itself from those heavy RDP protocols.
So what's the secret sauce? The tech stack.
It relies heavily on Node.js and Socket.io. These are technologies designed for real-time, bidirectional communication.
Break that down for the non-coder.
Well, when you use RDP, you are sending heavy data images, video frames. You're sending the result of the action.
Okay.
When you use this MEVIA system and you tap left on that virtual D-pad, your phone isn't sending a video of a button press. It is sending a tiny, lightweight JSON message.
JSON is just text, basically.
Exactly. It's a tiny string of text. Something like message.evt equals swipe left.
So that message shoots through a WebSocket.
Right, which is an open pipe between the devices. It goes to the server, which instantly relays it to the TV. Because the data is so small, the transmission is incredibly fast.
So we aren't streaming the game to the phone.
Right.
We're just sending the command from the phone.
Correct. The phone is just sending coordinates and events. User tapped X, user swiped Y.
The TV does the heavy lifting of rendering the
Yes,
graphics.
Precisely. The phone is just a remote trigger. This keeps the network load very low, which minimizes lag.
Oh, wait, I saw something in figures 7 and 12 about tunnels and video. So there are times when it does send heavy data.
Yes, and this is where the patent gets really ambitious. It mentions WebRTC.
Web real-time communication.
And this is for when you do need to move media, like the video conference use case.
This one is brilliant because it solves a hardware problem with software.
Right, so imagine you want to do a Zoom call on your big living room TV.
Which usually sucks because my TV doesn't have a webcam.
Nobody's does. You'd have to buy a separate camera, run a cable down the back.
Nobody does that.
But you have a high-definition 4K camera in your hand.
My phone.
The patent describes a setup where you look at the TV to see your family, but the system activates your phone's camera and microphone.
Oh, that's clever.
It creates a peer-to-peer WebRTC tunnel. It streams the video feed from your phone wirelessly directly to the TV.
So my phone is acting as a wireless webcam peripheral for the TV.
Yes. Figure 3 actually shows a microphone and camera controller interface.
So I just prop my phone up against a coffee mug and suddenly my dumb TV is a high-end video phone.
And again, no app. It's all happening inside the browser tunnel.
That is a feature I would use today. That feels like a genuine upgrade to the hardware I already own.
It maximizes the utility of the device you paid $1,000 for your phone and lends that utility to the dumb screen on the wall.
Now, speaking of maximizing utility, we've talked about touchscreens, but the patent goes into some sci-fi territory with what it calls magic wands.
Yeah, this is figures 11 and 22. This is where we stop tapping the screen and start moving the phone itself.
So it's using the phone's sensors.
The patent describes capturing raw sensor data, the accelerometer and the gyroscope.
So it's reading accelix, accelix, accelix. It knows how the phone is moving in 3D space.
Precisely. It turns your phone into a Nintendo Wii remote. The patent calls them 3D gestures.
So instead of tapping right on a Netflix menu,
You just flick your wrist to the right, like swatting the menu away.
or in a game, instead of pressing a button to cast a spell, you literally wave your phone in a specific pattern.
Wingardium Leviosa with your iPhone.
Okay, but anyone who has used a Wii knows that motion controls can be finicky. Does the patent explain how it tells the difference between me waving the phone and me just picking it up off the table?
It does, and this is where it gets technical again. Figure 22 mentions the use of neural networks and LSTM.
Long short-term memory networks. That's a type of AI machine learning, right?
It is, and it's specifically designed to deal with sequences of data over time. And LSTM remembers what happened a second ago.
So the system isn't just looking for movement.
No, it's being trained to recognize the signature of a specific gesture. It differentiates the jitter of your hand from the specific swoop of a command.
So it's personalized. It learns how I move.
Deeply personalized. In fact, Figure 25 discusses gesture authentication.
A secret handshake.
Exactly. Imagine if your password wasn't a typed string of characters. Imagine your password was a specific complex air gesture you make with your phone.
A biometric movement signature. That's wild. And probably much harder to hack than password 123.
Much harder.
I want to zoom out a bit. We've been talking about this in the context of my living room, but the patent uses this phrase, the MEVIAOS.
Yeah, it sounds a bit like a buzzword, doesn't it?
It does. But Figure 20 describes something that looks like a broadcasting ecosystem. How does this apply it outside the home?
This is where the commercial potential comes in. It mentions integrating with traditional broadcasters, Sling TV, Comcast, DirecTV. The idea is an overlay system.
An overlay.
Think about watching a football game at a sports bar. You're watching the broadcast feed. The MEVIA system can sit on top of that layer.
Okay.
You scan the QR code on the screen, and suddenly your phone has real-time stats, or a betting interface, or a poll for player of the match.
So it turns passive TV watching into an active multi-user experience.
Multi-user is key. Figure 10 explicitly mentions multiple UUIDs connecting to one session.
That's the second screen problem advertisers have been trying to solve for 20 years.
Exactly. They want us engaging with the show, not scrolling Twitter. If the controller is tied to the content, you stay engaged.
You could have 4 people in a room all scanning the same QR code on one TV.
And playing a trivia game against each other using their phones as buzzers.
Okay, but here's a practical snag. You mentioned a sports bar. I'm at a bar. There are 20 TVs on the wall. How does my phone know which one I'm trying to control?
That would be a deal breaker. But the patent anticipates this. It brings in another technology, location awareness via UWB.
Ultra-wideband. That's the tech in AirTags, right? For precision finding.
The very same. Figure 15 outlines a process where the system uses triangulation to determine your precise physical location relative to the screens.
So it knows I'm standing in front of TV number 4.
It knows you're 3 feet away from TV 4 and 20 feet away from TV 5. So when you open your browser, it automatically serves you the controller for that screen.
That is seamless. You just look at the object and your phone connects to it.
It makes the digital interaction feel physical. You look, you connect, you control.
We need to address the elephant in the room, though. Security.
Always.
I'm scanning a QR code in a public place. I'm connecting my phone to a strange network. Am I giving this random TV access to my photos, my contacts?
That is the vital question. The patent emphasizes that this entire process runs inside the browser sandbox.
Explain sandbox for the listener.
Modern mobile browsers, Safari, Chrome, are designed with high walls. A web page cannot just reach out and grab your files unless you explicitly give it permission.
Like clicking upload photo.
Right. The script running from the TV page cannot access your OS level data. It can't read your emails. It can only do what a standard web page can do.
Okay, that's reassuring. So it's safer than installing an app, really.
Much safer. An app has deeper permissions. A website is contained. Also, the QR codes themselves have security layers.
Like what?
They contain security credentials and timeouts.
So the code expires?
Yes. If you snap a picture of the QR code at the bar and take it home, it won't work 10 minutes later. It's a temporary session. And it's all encrypted.
It feels like they really thought about the architecture here. It's not just a cool hack, it's a platform designed for the real world.
It challenges the dominance of the App Store model. We're so used to, there's an app for that.
Right.
This patent says, no, there's a URL for that. And it's faster and safer and easier.
It's a return to the open web principles.
It really is. It treats the physical world, the screens around us, as just another extension of the web.
So let's wrap this up. What is the big takeaway here?
For me, it's about decoupling. Right now, our interfaces are glued to our appliances. The TV remote belongs to the TV.
And they are usually terrible interfaces.
They are cheap and dirty and static. This patent proposes that we decouple the interface from the machine.
The machine is just a dumb display.
Right. You bring the interface with you, you bring the logic, it lives in your pocket.
And because it's software, it can update instantly.
Exactly. A Tesla gets better with a software update. Why shouldn't your TV remote? The developer updates the code on the server, and boom, every user instantly has the new interface.
It makes the world around us programmable. Which brings us to our final thought.
It's a big one.
If this technology actually takes off, if our phones can instantly become the interface for any screen we walk past, does the concept of a personal computer change?
It has to.
Are we moving toward a world where we don't need to carry laptops or tablets? Because every screen is just a temporary blank canvas waiting for our personal digital identity to activate it.
A world where the computer is everywhere and nowhere at the same time. You walk up, the screen becomes yours. You walk away, and it's just glass again.
It's a fascinating future to imagine, and certainly beats typing passwords with arrow keys.
Anything is better than that.
Thanks for diving in with us.
Always a pleasure.
See you next time.